Hello children, our second chapter is about identity. And did you notice the family of identity, the Taravada? And the first house belongs to the house of square identities. A plus b whole square, a minus b whole square, a square minus b square, and a plus b plus c whole square. That is the first Taravada. And nearby cubical identities, a plus b whole cube, a minus b whole cube, and the factorization of a cube plus b cube and a cube minus b cube. A cube plus b cube equal to a plus b into a square minus ab plus b square. A cube minus b cube equal to a minus b into a square plus ab plus b square. And you have learnt its expansion and factorization. Then I told you one identity is left from this family. It is an identity but doesn't look an identity. That also you have learned. That is x cube plus y cube plus z cube minus 3xyz. Its factorization is x plus y plus z in one bracket into x square plus y square plus z square minus xy minus yz minus zx. And this is not used in mathematics. It is only the rare use in mathematics. And these are about the family of identity. Other than this, I move into the last section of this chapter. Suppose if you get an cubical polynomial, it is not an identity. Note this point. If it is not an identity, but it is a cubical polynomial, any cubical polynomial, how to factorize such question? Can you factorize such question? How? And see one example. Factorizing any cubical polynomial. This is an example. Factorization of a cubical polynomial x cube minus 2x square minus x plus 2. It is not an identity. But how will you solve it? Here we have to apply our remainder theorem. What is the remainder theorem? Any polynomial is divided by a linear polynomial, the remainder is 0. Or if the remainder is 0, you can tell that polynomial is a factor. So you have to replace x by 1, negative 1, positive 1, negative 2, any number. This is our trial and error method. You have to substitute x as these values, mainly 1 negative 1, 2 negative 2, 3 negative 3. If you get the remainder 0, you can assume or you can take that polynomial is a factor. And suppose the given polynomial is x cube minus 2x square plus minus x plus 2. We can start our first attempt. We can replace x by 1. Substitute x as 1. You got remainder 0. That means x minus 1 is a factor according to our factor theorem. X minus 1 is a factor of this. So you got one factor of this polynomial. And you know, a polynomial having degree 2, it has at most 2 factors. Similarly, a polynomial having degree 3, it has at most 3 factors. Among 3, you got one factor. Then how to find the other 2 factors? And now x minus 1 is a factor. Take it as a divisor. And dividend is x cube minus 2x square minus x plus 2. Divide it because these two are x minus 1 is a factor of this. So surely you will get 0 remainder. Divide, long division method. X cube minus 2x square minus x plus 2 divided by x minus 1. And the division is shown. You are getting 0 remainder. So x square minus x minus 2 as the quotient. How to write it? X cube minus 2x square minus x plus 2 equal to x minus 1, that the first factor, and the second factor x square minus x minus 2. And see, the second polynomial is a quadratic polynomial, second degree polynomial. Is it an identity? It is not a plus b whole square, a minus b whole square. It is x plus a into x plus b form that you have learnt in 8th class. It is an identity by using, we can convert into the factors by taking the sum and the product. Split into middle term. So take only the second degree polynomial, split in the middle term, you are getting other two factors. Now the factors are totally x minus 1, x plus 1, x minus 2. And this is another method of finding the factors of any cubical polynomial. I will post more questions for practicing such cubical polynomial. It is very, very important. If it is neither an identity, you have to solve, you have to factorize such polynomial by using our factor theorem, remainder theorem, by trial and error method. You have to substitute, replace x by these numbers. Thank you, and watch the video carefully.